This is real, and this is happening. We've come a long way from where we were just, a mere decade ago.
It's the breakthrough season for electric airplanes. ASML Aero, a cutting-edge aerospace startup headed by an innovative couple in Sydney, just scored a whopping $5.43 million from the Australian Renewable Energy Agency to revolutionize regional air transport. The reason? An eVTOL aircraft powered by hydrogen is set to flip the script on how we perceive air travel. But hold on to your safety belts because there's more than meets the eye. Supported by ARENA, Australia's federal body, and other prominent investors, this $10.86 million project could mark a turning point in aviation history. Should it succeed, it will become one of the most cost-effective and environmentally friendly forms of air transport for distances up to 1,000 km. In a press release, ARENA CEO Darren Miller heaped praise on AMSL Aero for being a leader in developing renewable energy solutions for the aviation sector, responsible for nearly 2.5% of global greenhouse gas emissions, with nearly a fifth coming from short-haul flights under 1,000 km. Additionally, Andrew Moore, co-founder and CEO of AMSL Aero, expressed gratitude for ARENA's funding and support for companies like his that are dedicated to clean technology and benefiting society. Founded in 2017 by the husband and wife duo, Andrew Moore and Siobhan Linden, this company is no stranger to the limelight. They've already developed a L aircraft named Vertia that's capable of flying up to 250 km at 300 km per hour. For quite a while, they've been planning to integrate hydrogen fuel cell technology into the aircraft to improve its range and versatility before its commercial launch in 2026.
The next one we're developing will use hydrogen, and it will have hydrogen fuel tanks, which will be in the wingtips of the aircraft.
According to reports, this advancement could potentially extend the aircraft's range to 1,000 kilometers, making it capable of connecting Australian regional hubs like Armidale to Coffs Harbour or Dubbo to Sydney. Also, it will cost up to 70% less to run than a conventional helicopter and be a lot quieter at just 65-70 decibels. And guess what? With 8 tilting wings and 8 rotors, Vertia has the capability to take off and land like a helicopter, making it well suited for diverse applications, including emergency services, air ambulances, freight, and passenger transport. Electric flights were first tested in the 1800s, with innovations continuing into the latter half of the 20th century. French military engineers Charles Renard and Arthur Constantin Krebs integrated batteries and an electric motor into an 1880s airship. The 1970s sparked a renaissance in the field, marking a resurgence in experimentation with electric and solar power. Over the past 2 decades, several notable electric flights, ranging from 20 minutes to several days, have taken place. Current research, particularly focused on passenger flights, coincides with rising jet fuel prices and calls from US and foreign regulators to reduce emissions. While internal combustion engine, ICE vehicles, commonly used today, rely on the combustion of fossil fuels to generate power, electric vehicles and planes are a different ballgame. In the former, fuel is mixed with air and ignited in the engine cylinders, which results in a mini explosion that drives the piston, ultimately turning the vehicle's wheels. But how about the latter? In electric propulsion systems, such as those found in electric vehicles or spacecraft, electric power is channeled to drive an electric motor, which propels the vehicle by rotating a propeller or a fan. Alternatively, in advanced systems like ion drives for spacecraft, electric power facilitates the ionization of a propellant, and the resulting accelerated ions produce thrust, showcasing the diverse mechanisms involved in electric power conversion for thrust in modern transportation and aerospace technologies. While we admit electric cars still haven't been able to surpass their gas-powered counterparts, they're still set to take over as the go-to choice in the near future. It's cost-effective in the long run and eco-friendly. Sharing similarities with EVs, electric planes bear some of the same challenges. Just as EVs can be weighed down by the weight of batteries, how exactly are electric planes going to overcome this challenge? Well, there are 3 basic methods used so far. Battery-powered. This design entails hooking the plane up with the appropriate supply of onboard battery power. Outfitting planes with onboard batteries started with the early electric flights in the late 19th century. While batteries power hobbyist radio control planes, well, their weight made piloting battery-powered planes challenging until fuel cell technology advanced. The first manned battery-powered flight occurred on July 16, 2006, with a light plane powered by 160 AA batteries, courtesy of students at the Tokyo Institute of Technology.
Today, all the people who say a clean aviation is impossible will look as stupid as the one who said to the Wright brothers, your airplane will never fly.
Solar powered. As the name implies, this is the use of solar energy to generate electricity. In the 1970s, designers tried to solve battery weight issues by introducing solar-powered planes. These aircraft used both batteries and solar energy and were slow and lightweight. However, they have the potential to stay airborne for extended periods, either as unmanned satellites or tethered to the ground like kites. Wireless power transmission. Another amazing method of delivering power to an electric aircraft is by wireless power transmission, or power beaming. This method utilizes either a ground-based laser or microwave emitter to transmit energy through the air to an aircraft equipped with a receiver. The initial application of microwave power transmission occurred in 1964, successfully powering a miniature helicopter for an impressive 10 hours. As we speak, developers around the world are frantically working on cutting-edge innovations in electric plane designs. Breakthroughs in propeller design, engines, and even fuel cell technology continue to push the boundaries of what is possible with electric flight. Now that ASML-0 has designed the world's first hydrogen vertical liftoff EV plane, there are a lot of things to be excited about.
I've worked with a broad range of technologies from batteries to biofuels and synthetic fuels to hydrogen, and came to the conclusion that hydrogen is probably the best answer.
By using hydrogen as a clean energy source, such aircraft could significantly reduce carbon emissions, addressing environmental concerns associated with traditional aviation fuels. Plus, given how hydrogen has a high energy density, this could also contribute to longer flight ranges, making it a viable option for both short-haul and long-haul flights. Moreover, the use of hydrogen fuel cells could lead to quieter and more efficient air travel, transforming the aviation industry towards a more sustainable and environmentally friendly future. Nevertheless, beyond the allure and buzz regarding electric aircraft design and technologies, it's worth adding that these aircraft haven't been perfected yet, and, in fact, are still far from the finished article. It's more than just swapping out an internal combustion engine and setting off into the sunset with a cleaner alternative. It can be really risky, and as a matter of fact, leading figures in aviation are still doubtful about the feasibility of electric passenger planes. Samuel Engel, the senior vice president at consulting firm ICF's Aviation Group, considers the concept of these planes operating like the daily afternoon Southwest flight from Atlanta to Las Vegas experimental, doubting if modern technology will be able to achieve this anytime soon. He also added that we're more likely to teleport in his lifetime than see large-scale commercial electric aircraft.
We believe it's going to happen sooner than most people imagine. If you fly on small commuter airlines today, you can expect some version of electric aircraft within the next 5 years.
However, don't take it the wrong way. Electric planes will take to the sky soon enough. The question, however, is how soon determined startups will make something work, given how there are still several obstacles stopping full deployment. Unlike a lot of other industries, aviation is fundamentally conservative. They can't afford to take significant risks because planes falling out of the sky can be quite chaotic. This makes innovations in aviation slow, as every facet has to be perfect with endless counter-arguments. When it comes to electric aircraft, basic engineering challenges need to be conquered or lessened at the very least. Weight is the first big problem. Jet fuel has a much higher energy density, around 50 times more than batteries, and unlike the former, which burns off and makes planes lighter during flight, batteries retain their weight as they lose charge. This presents a challenge as it means carrying dead weight that requires recharging, adding complexity to the situation. And what about the batteries? Even if we were able to power up the aircraft with modern motors that provide a lot of power with little weight, juicing them up would be another problem. To solve this, cutting-edge firms are developing charging trucks that come to the planes at airport landing strips to charge up the crafts, essentially making mobile battery-to-battery charging stations. But guess what? There's still a big problem there. Right now, there are limited power and charging sources, lackluster airport infrastructure, and don't even get us started on the regulations. The FAA required decades to embrace composite structures in airplanes, as illustrated by the full composite Boeing 787 Dreamliner introduced in 2009 and the geared turbofan engine. How long will it take for EV measures to be accepted? All of these are reasons why skeptics are placing their bets on hybrid electric planes to take off sooner than their all-electric cousins. Now that the hydrogen-powered EV project is going full swing, how excited are you about its impact on the future of air travel? Also, considering the challenges faced by electric propulsion of such scale, do you think commercial electric aircraft travel is feasible in the near future? Keep the conversation going in the comments section below.